Welcome to Lesson 8. So today we'll be switching gears and we'll be talking about area. So let's get started. So to begin with, what exactly is area? Well, let's quickly review what perimeter is. So recall that if I have a box or a rectangle and I ask you to find the perimeter, we're finding the distance around, right? That's what perimeter is all about. So we're taking the length of this side and we are adding it to this side, and then we're adding it to this side, and we're adding it to this side, right? We're just finding the distance around the shape. That is perimeter. So now let's look at area. To begin with, let's just get the definition out of the way. So area is simply equal to the number of square units that can occupy a flat space. Okay, so that may sound complicated, but let's figure it out. So if we take this same shape and ask ourselves, well, what would be the area of the shape? We know how to find the perimeter. What would be the area? The area is the space contained within this shape. So it's all of this space in here. This is all considered the area. All right. Now notice that this is a flat shape. That is important too. Later on, we'll discuss how to find, how to measure the space occupied by a three-dimensional object, such as, something like this. That would be a completely different scenario. Here, we're only applying area to flat spaces. All right. So how do we find area? To begin with, let's discuss what a square unit is. All right. We'll begin with that. So what is a square unit? Well, when we think about measurements, there are many things in this world that we might want to measure. You might want to measure, for example, how tall you are. Or maybe I have a line that looks something like this, and I want to measure how long the line is. I could measure this in different units. And then we have many kinds of units that we could use to measure a line such as this. Think about some units that you know. We know inches, we know feet, we know yards, but we also know other units as well. We know ounces, pounds, cups, pints, quarts, gallons, all kinds of different measurements. We have measurements of time, seconds, minutes, hours, right? So how would you measure this particular line? Well, you would use units of measurement, right? Units of length. So we would use inches or feet or yards or miles, whatever we want to use to measure this length. Now, the important thing to remember is that all of these, inch, feet, yards, miles, they're all measuring linear objects, which just means that they have a length and nothing else, right? So if I'm trying to measure the length of a string, that's great. I can use these things. However, if I want to measure the, we're talking area. So if I say I want to measure the area of this space, maybe this is my dog pen, okay, and I want to measure how big my dog pen is. How could I measure this internal space within the pen? I couldn't really use feet. That wouldn't really tell me. I mean, I could say that it is, maybe 10 feet wide, and maybe I could say it's, 20 feet long. And that would give me some idea, but it really wouldn't measure this internal space, okay? To measure internal space, we need different units. Just feet all by themselves, that doesn't actually work for us. So we need something that's called a square unit, okay? Now, a square unit is exactly what it sounds like. It is just a square of a given dimension. So it's got to be a perfect square. So maybe this, and I know this isn't to scale, but let's pretend like this is a 1-inch square, which means that this side is 1 inch. Whoops, sorry. This side is 1 inch. This side is 1 inch. And this side is 1 inch. All sides are 1 inch. It's a perfect square, okay? Now that would be what we would call a square inch. There's a couple different ways we could write this. Square inch, we could call it an inch squared, or we could abbreviate it and just say inch squared. All right, all of these mean the same thing. It means we have a square that's an inch on all sides. Now, if I wanted a square foot, we could do the same idea, only just, a larger square. So if I have, something that looks like this, maybe this represents, a square foot. In which case all of our sides are going to be a foot long. This would be a square foot. So I'll call it a foot squared. 1 foot squared. All right. So these are a different set of units. Whenever we have these square units, we have this little 2 up in the corner above the dimension, foot, inch, so on. These are what we'll be using to measure area. And the whole idea is to figure out how many of these units can fit into the shape that we're trying to find the area of. All right. So let's try a couple. Just let's take a couple examples here. So let's say I have a rectangle and I want to find the area for this rectangle. How am I going to do it? Well, the working behind the scenes is that we're going to choose a unit. And let's say we choose the square inch unit. All right, so we're taking these little boxes and we're saying, okay, this is an inch square. How many of these can we fit into this rectangle? So how would we do that? Well, we would start by just stacking these square boxes into this rectangle and seeing how many could fit. So once we did that, we would end up with something that looks like this. So here I have all my little square units all stacked in place inside my rectangle. And now I can count them up and see how many fit in this rectangle. So I have 1, 2, 3, 4, 5 across the top. So I have 5 rows, or 5 columns, I should say. Each column has 1, 2, 3, 4 in it. So 5 row columns with 4 in each column. 5 times 4, I have 20. So I end up with 20 inches squared. Notice this is very important. It's not inches. That would be the wrong unit. It makes no sense to say that the area is 20 inches. All right, it has to be 20 squared inches because now we're using 2 dimensions. We're using a length and a height, or a width and a length, you might say. All right. All right, so knowing this, let's look at rectangles. If I have 4 units off on one side, so I have 4 boxes stacked up over here, and then I have 5 stacked up over here, a simple way to find the area was to take the 5 times the 4. That would give me the total number of boxes within this rectangle. And that's the formula we're going to use to find the area for rectangles. It's that simple. So area for rectangles, maybe I'll just jot that in here, rectangles. The area is the length times the width. All right, that is the formula. If I know how long this line is, let's say this line is 4 inches. Okay, well, that means that I can make 4 1-inch boxes out of that line, right? Or that line makes up 4 sides of 1-inch boxes. I've got 1, 2, 3, 4, right? And then if I have a length of 5 across the top, well, that means there's enough line there to create the sides of 5 different boxes. All right, so if I just know the length and the width, I can multiply those by each other to give me the final area. 4 times 5 is 20 inches squared. All right, very good. So it's that simple. All right, so we've discussed how to find the area of a rectangle, but what if the shape is not a rectangle? So for example, what do we do when the shape is like this, a triangle? If the shape is a triangle, it can be kind of tricky to get our squares in place, right? So if you kind of picture, me drawing in these squares here and trying to stack them up, eventually we're going to get up here where we don't really have a full square in the triangle. We actually have kind of a half of a square in the triangle for this example. So it gets a little bit harder to visualize how we're going to stack all our squares in here. So the way we're going to find area for triangles is actually through a neat little trick. And that is that every triangle's area is exactly half the area of a box that it could be contained in, based on its height and on its base. Okay, so for example, in this particular case, if you take this triangle, and now I'm going to take this triangle, and we're going to actually just get another triangle the exact same size, only we're going to flip it. We're going to turn it on its end like this, all right? And if I take that triangle and stack it onto the first triangle, we see how we actually form a square, right? Is that cool or what, right? So if it forms a square, well, a square is just a rectangle. And we know how to find the area of a rectangle. It's length times width. But we don't want the area of this full rectangle. We only want the area of this portion of the rectangle, right? Because that's our actual shape. So we want the area of exactly half of the rectangle. So based on that, we can arrive at a formula for solving the area of a triangle. And the formula is this. So I'm going to put area, and then below it, I'm just going to write triangle so we don't get confused. We already know that the area of a rectangle, and maybe I'll just put an R under there for rectangle. Area of a rectangle is equal to length times width. Well, now the area of a triangle is going to be essentially length times width, but we're going to call it by two different names. We're going to call it the base times the height. Okay. So this will be our base. This will be our height. And if you think about this in terms of our square here, our rectangle, that would be the same thing as the length and the width of a rectangle, right? It's the sides. Only here, it's in a triangle. So we give it different names. We call it a base, and we call it the height. And we'll especially talk about height later, because that's probably the trickier one. So, but we have the base and the height. We're going to multiply those two by each other. Now, if we multiply the base times the height, what we're actually getting is the area for not just the portion that we want, but also the portion of this whole square, right? So base times height is going to give us the area of the box. We don't want that. We want half of that. So what we need to do is take our formula and divide this by 2, right? Because we only want half of it. So we're going to cut it in half by dividing it by 2. So that is the formula for the area of a triangle. Okay? So maybe just a really quick example. If I have a triangle that maybe looks like this, we'll just make it similar to the last one. And if this is, let's say the base is 3, the height is 4, the area for this triangle is going to be the base, which is the 3. Think of it as kind of the bottom of the triangle, times the height, how tall the triangle is. It's 4. And then we're going to divide that by 2. So 3 times 4 is 12, divided by 2 is going to be 6. So we end up with 6 units squared, because again, I didn't give you units for this problem. We'll just call it units squared. All right? Very good. So that is how you find the area of a triangle. Now, triangles can be tricky because they don't always look like this. This is a nice 90-degree right triangle, right? Sometimes triangles are a little bit more confusing than that. We might have something that looks kind of like, you know, some weird triangle that maybe looks like this, right? Now, in order for us to find the area of this, we need to know what? We need to know the base and we need to know the height, right? Because the area for our triangle is base, I'm going to represent that as a B, times the height, represent that as an H, divided by 2. Another way to write this, by the way, would be 1/2 times base times height. It's the same formula. It's just the half is taken out. All right? So what do I need? I need to know the base. And the base is going to be down here. This is going to be that bottom line. So that's pretty straightforward. The height, though, can be a little bit tricky because the height is not this side. It's not that side. And it's not this side. All right? The height has to be how tall the triangle is. And that's always with respect to the base. So here we have our base. The height of this triangle is going to be from here up to the tip-top part of that triangle. That will be the height. Okay? So be careful with that height. It can throw people off. It's not the length of one of the sides of the triangle necessarily. It was the length of the side of the triangle for this one, but that's because this height was the side of the triangle. All right? Here it's a little bit different. So we need to know the height and we need to know the base. Once we know these things, then the rest is straightforward. All right? We multiply them together, divide them by 2. So 3 times 10 is 30, divided by 2 is 15. So we'd end up with 15. Let's just say it was in inches squared. Okay? All right, very good. Now, let's talk about the area of a circle. Moving on. All right? there is another formula that we're going to use, and we're not going to just go into the proof behind this one too much. We're just going to take it a little bit on blind faith here. It's just outside the scope of this math class. So the formula for the area of a circle is, and I'll put area sub c, so that c will stand for circle. So, or if you want to write out the whole thing, that's fine too, area of a circle. And it's going to be equal to pi, so our old friend pi again, just like in perimeter. But then it's going to be pi times radius squared. Okay, that is the formula for finding the area of a circle. So just to refresh your memory, the perimeter of a circle. Do you remember the formula for the perimeter? Actually, I should probably say more correctly, the circumference of the circle, which is just the perimeter. The circumference of the circle is equal to, remember what it was? It was 2 times pi times r, 2 pi r, or you might say the diameter times pi. Okay, so that was the formula for the circumference. Notice how it is somewhat similar to the formula for the circle, the area of the circle, but the r is different. So we still have the pi, but we have an r raised to the second power, all right, instead of a 2r. Okay, so memorize that formula because you'll need it. Now, if we have this circle, let's say the radius is a 10. All right, 10 feet. Say it's in feet. 10 feet is the radius. How would I find the area of the circle? Again, how many squares could I fit into this circle area? Well, we're going to take our area is equal to pi times the r, which is 10 squared. And what does 10 squared mean? We haven't really talked about that, I guess. What does 10 squared mean? Anything raised to a 2 means that it's being multiplied by itself twice. So, 5 squared is equal to 5 times 5, which is 25. 6 squared is equal to 6 times 6, 36. All right, it's just multiplied by itself twice. That's what this little 2 power means. Okay, so we have r squared, meaning 10 squared in this case. 10 squared is 10 times 10, which is 100. So we end up with pi, which remember is approximately 3.14 times 100, which that's an easy multiplication problem because it's being multiplied by 100. We can just move the decimal twice. That's going to give us 314, and we said it was in feet, so it's feet squared. All right, so it'd be 314 feet squared. That's the size of this area within the circle. All right, so if you haven't done it already, make sure you write down in your seat work the formulas for the area of a rectangle, the area of a triangle, and the area of a circle, and make sure you have those memorized. Now let's end the class by just taking a couple of examples here and seeing how they can use all three of these formulas together sometimes to find the area of particular shapes. So here we have basically a rectangle within a rectangle, and let's say that we're trying to find the area of the larger rectangle, the light gray rectangle, without counting the area of the dark rectangle inside. All right, so we just want the area of the lighter gray. How could we do that? Well, the first thing to recognize is that these are in fact two rectangles, and we know how to find the area of a rectangle. And if we're really looking for the gray area, we need to then subtract the darker area from the lighter area. Does that make sense? We're just going to find the area of maybe this whole outside box, everything inside. And once we have that number, we can subtract the area of this dark rectangle, and that would give us what's left over, which is what we want, the light gray box. Okay, so kind of having that plan in mind, let's go through the steps. So how would I find the area of the larger rectangle? Well, because it is a rectangle, we know that the area is equal to length times width. And the length in this case, we'll call the length 12. It doesn't matter which side you choose to mark as length, but I usually choose the longer side to be the length. So we're going to say that the area for the outer box, the large gray box, is going to be the 12 times the width, which is the 8. Right? which is 96, and we'll just say this is all in centimeters squared. All right, so we'll kind of box that as our temporary solution. All right, that's the area of everything. But I don't want the area of this dark gray added into this. So let's first find the area of the dark area, or the area of the dark rectangle. So again, we're going to choose, area equals length times width. The length here will be 8, right? And the width will be 3. So we have 8 times 3, which is equal to 24. And again, it'll be in centimeters, so centimeters squared. We'll box that. So now we have kind of our two temporary solutions, or minor solutions. But now our final solution is just the light gray area. So we're going to take the area of the whole box, subtract the smaller box to arrive at our final solution. So we have the 96 from here, and we're subtracting from that the 24, which is going to give us 72 centimeters squared. So our final answer is going to be the 72 centimeters squared. All right? All right, let's try another one. This is another kind of problem that they can throw at you. So here, this is an irregular shape. It's actually kind of a composite shape. It's made up of other shapes, okay? So if we look at this, we have to kind of use our heads a little bit, and let's actually throw some measurements in here. So let's say that this is, 5 units. Maybe this is 10 units. We'll call this 2 units, and we'll call this, 5 units as well, maybe. How's that? All right. And based on those measurements, can we find the area of this shape? Well, to do so, we have to get creative. We need to cut this up into doable shapes because we do not have a formula for finding the area of an L-shaped shape. So we need to divide this up into shapes that we know how to handle. So there's a couple ways that we could do it. We could divide this up like right here, right? We could cut this like that. And then you can see that we'd have this kind of long, skinny rectangle. And we know the length and the width of that. It'd be 2 and 10, right? And then we'd have this smaller rectangle up here. However, we wouldn't really know the length and the width on this. We could figure out this side. And actually, we could figure out this side. We could figure out both sides. So we could make that work. All right? You might be asking how I can figure out this length here and this length here. Maybe pause the video and think about it for a second. But you can figure out those two lengths based on the numbers that they've given us. However, there may be an easier way to do this, so let's back that out. What if we divide our shape up this direction? Now, if we divide it up this way, we have this smaller little rectangle to the left and then the larger rectangle to the right. And do we have our dimensions here? Well, once again, for this smaller rectangle, certainly the length is 5. The width is 2. That's easy. For the larger rectangle, we know that the length here is 5. So that's given to us. But we do need to know what the width is. And that's something we're going to have to figure out. Maybe take a minute. Can you decide what this length is going to be? This width? Well, think about it. So this bottom is 10, and they tell us that all the angles are right angles. That's important. That means we can do what we're about to do here. So this bottom is 10. Well, that bottom is the same length as this line added to this line, right? If I take these two red lines, glue them together, I now have the length of my bottom line, right? So if that's the case, how can I figure out what this line is? The bottom line is 10. This line is 5. So if I take the 5 away from the 10, I end up with 5 left over. So this top has to be 5 left over. Now, clearly this is not to scale because this line is supposed to be the same length as this line, and clearly they're not in the drawing. But mathematically, that's the way it would have to be. All right? So that would also have to be 5. And now we have our width and our length for our larger rectangle. So once we kind of have a plan on how we're going to cut this up and find the areas for each section, we can then go ahead and start doing the work. So let's first take this box here. All right, so we're going to take this box. Area is going to be equal to length times width. And that's going to mean it's 2 times 5, which is equal to 10. and we'll call this inches. Inches squared. So we have 10 inches squared for this section, right? Now let's figure out the other section. So here we're going to have area equals length times width, and we're looking at this box, and we know that the length and the widths are the same. They're both 5, so that's supposed to be a square. Doesn't look like it though. So the area is equal to 5 times 5, which is equal to 25 inches squared. So now we have this area, and to compute the area of the whole shape, we just need to add these two together. So 25 inches plus 10 inches squared are all going to be 35 inches squared. That would be our final answer. All right? Very good. Now we're combining a couple of other shapes. Now we have clearly a rectangle and a triangle. So why don't you pause the video and see if you can figure this out on your own first, and then we'll do it together. All right, so as we said, this looks like a rectangle combined with a triangle. So we need to use two of our formulas, our rectangle formula and our triangle formula. So it doesn't matter which one you want to attack first. Let's just say that we want to attack the rectangle first. So we're going to take this section, okay, and find the area for that. And for that, we need to know our formula, which is length times width, since it's a rectangle. Our length is 8. Our width is 4. So we have 8 times 4. It's 32. We'll call this feet squared. All right, so that's our rectangle portion. Now we need to figure out the triangle portion, this area. So what's our formula for the area of a triangle? That's area equals base times height divided by 2. All right, so what's our base? Our base is 4. That's the length from here to here. So that base is 4. What's our height? Well, our height would take us from here at the bottom up to the top, the peak of the triangle. And that's actually the same length as the side of the rectangle. So that's going to be that 4. So here we have a base that's 4 and a height that's 4. So we'd multiply base times height. Don't forget to divide it by 2. 4 times 4 is 16, divided by 2 is 8. So we end up with 8 feet squared for our triangle portion. And then the final step here is just to combine everything. So we have 32 feet squared and we have 8 feet squared. We combine those together and we end up with 40 feet squared. So that is our area for this shape. All right. Very good. One last one before we call it quits for today. We're going to combine all three of the kind of shapes that we learned today. So go ahead and pause the video. Try this one on your own, and then we'll do it together. All right. So really it just depends on your preference, what part of this shape you want to attack first. Maybe let's attack the circle first. All right. So let's find the area for this part of our shape. All right, so we need a circle formula. So our circle formula is area equals pi r squared. All right, so we have pi times our r. What's our r? It's 2. That's our radius, right? So it's times 2 squared. And 2 squared is just 2 times 2, which is 4. So we end up with, I'm just going to write this as 4 times pi, or 4 pi. All right, just for right now. Instead of multiplying that as 4 times 3.14. That's fine. We can leave it like this. So that area is 4 pi. However, let's think about this for a second. Because this is the area of a full circle, right? A full circle. This is not a full circle. In fact, this is a half of a circle. So therefore, we're going to want to find half of the area of a full circle. So don't forget this step. This is the area of a full circle. We need half of that. So what are we going to do? We're going to divide that by 2. And if we divide that by 2, we're going to end up with 4 divided by 2, which is going to cross cancel, and we end up with 2 pi. Whoa. Going crazy here. 2 pi. All right, so that is the area for this half of a circle. Don't forget that this is a half a circle, so you need to cut your formula in half. Okay? All right, now let's move on to the next one here. What about this rectangle? He's usually the easy one. All right, how do we find the area of that? Well, we know that the area is going to be equal to length times width. So what's our length and our width? Well, the width is maybe the easy one here. They give us that right up front. The width is 3. So we can plug that in for our W. But what about our length? They don't tell us really how long this dotted line is, and they don't tell us how long this dotted line is. So is there a way that we could arrive at that length based on what they did give us? And the answer is yes, there is. Let's go to this origin here of the circle. Okay? Now, if I extend this line out to here, that's 2 inches. But remember, the radius is the same around the whole shape. So this would also be 2 inches. This would also be 2 inches. This would be 2 inches. Anywhere around here, this is all 2 inches long, right? So if I just bring that all the way down here, point it straight down, that's 2 inches down. And if I were to draw another radius straight up from the origin of the circle, that's also 2. So I have 2 here and 2 here. So if I combine those 2 radii, I end up with 4. And that's going to be the length of this rectangle, right? Hopefully that makes sense. We can use the radius to find the length. So our length is 4. And now it's just multiplication. 4 times 3 is 12. So we end up with 12. And I didn't give units over here either. I should have. Shame on me. Let's just say it's feet. So feet squared. And then over here, we're going to have 12 feet squared as well for our rectangle. And then finally, we have our triangle. So we have this shape here. And what's the formula for a triangle? The area is going to be equal to base times height divided by 2. Well, what's our base? Our base is clear. That's 4. That's the measurement from here to here. There's our base. What's our height? Well, our height would be from here to the top of the triangle, which is here. That would be the same length as the side of this triangle. And the side of this triangle will be the same length as the other side of the rectangle, which we said was 4. We said this was 4 over here. So this is also going to be 4 over here by virtue of all these right angles in the rectangle. All right. So we have a height of 4. So we have base 4, height 4, once again. So 4 times 4 divided by 2 is going to give us 8. Once again, it's 8 feet squared. So now we have all of our lengths, or all of our areas. We can just combine everything. So 2 pi, well, we can multiply that out. So 3.14 times 2 is going to be 6.28, right? If we do the multiplication here. So we have 6.28. That's the same as this guy. All right, so we have 6.28 plus our 8. Remember, we need to line up our decimals here. 8 plus our 12, put that on top just to keep organized. And we add all that together. We're going to end up with 8, 2, decimal point. Let's see, 14 and 2 is 16 and 26. So we have 26.28 feet squared. That is the area for this whole shape. All right, so hopefully this has all made sense to you. Bottom line, make sure you have these formulas written in your homework notebook or your study notebook and memorize them so that you can apply these to future problems. All right, so I hope your seat work goes well, and I will see you tomorrow.